I am Ennemcien. Let us see what does instantaneous center of zero velocity mean. Before that, we must know the basic types of motion. One is pure translation. Second is pure rotation. And the third, combination of translation and rotation. The rest of motions, complicated motions, are composed of these elements, these basic types. This is a railway coach. It is moving to the right. Center of mass of the coach is C. As the train moves, position of C changes continually along a straight path. This motion of the center of mass is nothing but pure translation. The coach is in pure translation. As a representative point, we refer to the center of mass as taking part in pure translation. Pure rotation, that means, say in short, in pure translation, center of mass moves along a line. It changes its position continually along a straight line. That's all. Then, this is a circular disc. It is mounted on a fixed axle and is set rotating. So here the center of mass does not change its position. It simply remains where it is. This is a simple example of pure rotation. So in pure rotation, center of mass doesn't move. And about the center of mass, other particles of the body rotate in different circles or circles of different radii. That is pure rotation. Here the major factor is angular velocity and tangential velocity and angular acceleration and torque. These are the main factors involved in pure translation. In pure rotation, in pure translation, the contributing factors are mass, linear velocity or rate of change of displacement, and the cause of translation, that is force. This is an example of combined motion. Here a circular disc is rolling on a horizontal plane. Here the center of mass moves along a straight path parallel to the surface. That is pure translation. But as it moves, the circular disc rotates and it moves forward, rotating itself. So here the two motions are combined. Translation of the center of mass and rotation of the rest of the particles. So this is the plain general motion or combination of translation and rotation. Now we have to, another example is a ladder inclined ladder, one end of which presses against a vertical wall, the other end rests on a horizontal floor. It can slip if there is no sufficient friction. Then this lower end will move along the horizontal direction with a certain velocity. The upper end will come down with a certain velocity, say VA. At the same time, it makes an angle theta during the process. Angle theta, generation of the angle theta means there is some kind of rotation. So there is linear motion here, and a rotation about some point. We have to find out where is that point. That comes instantaneous center of zero velocity. And we have to see the instantaneous center. Here you are. You take up with the rolling of a circular disk on a horizontal surface. At some point of time, the point P1 on the rim of the disk is in contact with the solid surface or ground or horizontal plane P1. And this P1 appears to be at rest for a moment. Next, after some time, this P1 is replaced by another point, say P2. As the disk revolves or rolls towards the right, P2, this point P2 will come into contact with the ground. At that time, P2 is the instantaneous center. Then comes another point, we take it, say P3. This P3 will come into contact with the horizontal surface. So, the point on the rim of the disk which touches the floor or horizontal plane is the instantaneous center in this case. There are some properties for this instantaneous center. When P1 just touches the horizontal plane, velocity of P1 is momentarily zero. That's why the P1 is called instantaneous center of zero velocity. This is not a fixed point because P1 will be replaced by successive points beyond P1 on the rim. So, instantaneous center is a point about which the entire disk appears to rotate for a moment. So, at the time or at the instant P1 touches the ground, an observer on the ground feels that the entire circular disk turns about this point P1. Just for a moment, P1 acts as a center of rotation. See here the significance of instantaneous center is that the combined motion can be reduced to pure rotation for an instant so that we can solve problems of combined motion using the principle of pure rotation. There is a significance. Now, as P1 comes here, its velocity is zero. As P1 leaves that point, it becomes accelerated. So at the point or at the point of instantaneous center, there is an acceleration. That particle or that point acquires an acceleration as it leaves that point of contact. So there are a few points to be discussed. 1. Instantaneous center is not a fixed point. Instantaneous center goes on changing. We speak of instantaneous center only for a particular instant. Next instant, instantaneous center is some other point. So instantaneous center goes on changing. Second point is that instantaneous center at the particular instant is at rest. That is why the name instantaneous center of zero velocity. Next point is instantaneous center acts as the center of rotation for a particular instant about which all other particles in the body appear to be taking part in pure rotation. So these are the main features of instantaneous center of zero velocity. So if you fix the instantaneous center at a particular time or particular instant, you can find out velocity of every particle in the body at that instant using this center and distance of the particle from this center. Keep it in mind that in pure rotation or circular motion, velocity, linear velocity is always perpendicular to the line joining the center of rotation and the point where we have mentioned the linear velocity. Or in short, linear velocity or velocity of any particle in the body, it will be perpendicular to the instantaneous radius of rotation. Instantaneous radius of rotation means the line or distance from the instantaneous center to the particle under our observation. C is the center of the disk or center of mass of the disk. This is moving. This is in translation, pure translation, and its translational velocity is Vc. When P1 is this instantaneous center of rotation or zero velocity, this C appears to be taking part in a circular motion of radius capital R. So that Vz equals r omega, this r into the angular velocity at that instant. If we take another point on the rim, at the extreme point of the rim, say P4, the velocity V4 is perpendicular to this line. Now now you take the problem as a circular motion with the center P1 and radius 2r, so that this V4 happens to be the tangential velocity at this instant we have considered. So V4 equals this distance into omega, r omega, that is 2r into omega, and so on. So this is another point P2. P2 is now in circular motion at this particular instant with P1 as center and P1, P2 as the radius. So velocity at this instant, velocity of P2 at this instant, V2, is perpendicular to this radius P1, P2. This is at another point, P3, where velocity is V3. Now the radius of rotation is this distance, and V3 is perpendicular to this line. Now it is the radius, instantaneous radius. I think you have got the concept. Okay. Now, next step is, so when we solve problems using this, instantaneous center is used to solve problems connected with combined motion. To solve the problem, the first step is to locate the instantaneous center. We will do it in the next posting. Thank you.